So right now we are going to review how to find domain and range when given a continuous function. Now, if you remember the definition from class of continuous is when your graphs are connected with a line. All the points on your graph are connected. It's not just random points. So there's a few things that we need to look at before we get started. And those are the endpoints. So I'm going to write this down. We're dealing with continuous functions or continuous graphs. The first thing that we have to pay attention to is the endpoints of our graph. We have three different types of endpoints when dealing with continuous functions. We have an open circle, a closed circle that's shaded N, or an arrow. Each of these mean different things. When you have an open circle, that means your point is not included in your graph. When you have a closed circle, that means your point is included. And when you have an arrow, that means your graph goes on forever. Okay. So every time we deal with domain and range on a continuous graph, we have to pay attention to what our endpoints are. These endpoints also help us decide what type of symbols we are going to use, or what type of inequality symbols we are going to use. So if we have an open circle, you can either use less than or greater than, because that point's not included. It's not going to be equal to. If you have a closed circle or a filled in circle, you can either use less than or equal to, or greater than or equal to. Okay. So we're going to take a look at this function first. This is a continuous function because our graph is connected. It's not just a bunch of random dots. It is all connected. So the first thing that we have to do is we have to deal with domain. So I'm going to write down domain right here. When dealing with domain, we have to pay attention to our x-axis because domain deals with our x values. We don't care about our y-axis right now. We only care about our x-axis. So what we have to do, and I'm going to break out a few index cards for this, is I am going to look at our function, and I am going to find my point furthest to the left and furthest to the right. Okay. So right here, I'm going to take my card and I'm just going to slide it through my graph until I hit the first point. Up, right there. I'm going to do the same thing coming from the other direction. Taking my card and sliding it until I hit the first point on my graph. Right there. My entire graphed function exists between these two index cards. So what I'm going to do now is on my x-axis, I'm just going to shade or highlight or draw a line so that way I know that's my graph. Okay. Now I can take these cards away. This line represents all of the x values inside my domain. It's every x value that exists on this graphed line. Now I have to look at my graph and I have to find the values of the two endpoints, the two ends of this highlighted line. Okay, so right here is the end of that line. And that x value is negative 2.5 because it's in between negative 2 and negative 3. My line ends right here, which is 3. So I know that my domain is going to be from negative 2 to 3 because those are the x values at the end of the graph. What I'm going to do now is I'm going to take those two values and I'm going to write them down right here. Negative 2. I'm going to leave some space and I'm going to put 3 right here. We're dealing with domain, so I'm going to put an x in between. So right now I have my two endpoints, negative 2 and 3. And I have x in between for domain. Okay. Now we're going to take this graph, or this chart, and we're going to look at our endpoints on our graph. So I'm going to put my index cards back on at the end of the graphs. My point furthest to the left on my graph, that is the first point on this graph, has a closed-in circle. Has a closed-in circle. So we're going to use a less than or equal to. Since it's the smallest point, it has to be smaller than everything. It can't be greater than. So it's smaller than. So I'm going to put right here, less than or equal to. Now, all the way over here, I also have a closed circle as well. So we're going to go back to our closed circles. Closed circles means you can only have a less than or equal to or a greater than or equal to. With this, we're writing x is something 3. Is x going to be bigger than or less than 3? It's going to be less than 3 since 3 is the biggest point on our graph. So this is going to be less than or equal to 3. That's how you find domain. Range is going to be the same thing, but we're going to work in our y direction now. Actually, I'm going to switch up to red. Range is the same thing, but we're just working in our y direction because range deals with y values. That's not how you spell values. And that's not, scratch that, y values. So I'm going to take my index cards again, and I'm going to start from the bottom. And I'm just going to move my card all the way up until we hit the first point, which is right there. Now I'm going to move all the way from the top till I hit the first point on my graph, which is right there. Now I'm going to do the same thing again, but on the y-axis. I'm going to take my highlighter and highlight my y-axis from the first index card all the way to that bottom index card. Okay, move those out of the way. We're going to find our values, our y values now, of the top and bottom of that line. So up here, that's 16. We stopped our line at 16. And right here, I'm going to call it 10. So, or negative 10, sorry. So our y values go from negative 10 to 16. We're going to do our range the same way. So we're going to start with the smallest number, negative 10, and the biggest number, 16. This time is range, and range deals with y. So instead of putting an x, we're going to put a y in the middle. Okay, now let's go to the bottom of our graph again. At our smallest y value point, I have a closed circle. So once again, I'm going to use less than or equal to. At my biggest y value point, I don't have any circles or any dots. Since this point right here does not specify that it is an open circle, we are going to assume that it's a closed circle and it is included in our graph. If it doesn't specify otherwise, we are assuming that it is included in our graph. So our domain is -2 is less than or equal to x less than or equal to 3, or all real numbers greater than or equal to -2 and less than or equal to 3. Our range is -10 is less than or equal to y less than or equal to 16. Or all real numbers greater than or equal to 10 at -10 and less than or equal to 16. And that's how you find domain and range if you're looking at a graph like this. We're going to switch it up now and use a graph like this. It is the same steps, but it's a little bit different. So now we're going to be dealing with something else. We're going to be dealing with arrows. So I'm going to do my domain. And once again, domain is your x. So I'm going to start all the way over here and I'm going to work my index cards in. Okay? Right there is kind of the endpoints, but it's different now. Because do you see these arrows? That means this graph goes on forever and ever and ever in directions, and that is not actually bounded. These arrows mean that this graph goes on forever in both directions, and it is not bounded on the x-axis. So we're going to highlight the whole x-axis. And we're going to say, because it doesn't have specific endpoints, it has these arrows telling us a very specific thing. Our domain is all real numbers. We're going to look at range now. And once again, range, this problem is going to be a little bit different. Range also deals with y. So I'm going to use my index cards and I'm going to start from the bottom and work my way up. Okay. So right here is the bottom of my graph. I'm going to work my way down. I can't because I have an arrow pointing all the way up. That arrow on top is continuing on forever and ever and ever. So I'm going to take my highlighter and I'm going to highlight from this index card, which is the bottom of my graph, all the way up because this does not end. There's an arrow telling me it goes on forever. Now I'm going to figure out this value. The y value right here is at 1. I can't figure out my y value up here because it continues on forever. So I know that my range is going to be bounded by 1. Is all my numbers going to be greater than 1? Or is it smaller than 1, less than 1? Everything greater than 1. So y, your range, is going to be greater than or equal to, because this is a closed circle, than 1. I don't have a bound. I don't have two numbers that I can write down here like this first example. I only have one number because we don't know where this graph stops. So it's all numbers bigger than or equal to 1 right there. And that is how you find domain and range.